Okay, good day. This is a lecture on ordination proportion sample problems. We will be continuing on answering some of our problems presented. This module is available in your Moodle, so if you wish to answer it on your own, the problems are posted online. So first, let's start. So the first question is, if an insulin injection contains 100 units of insulin in each milliliter, how many milliliters should be injected to receive 40 units of insulin? So as in any relation proportion problem, we need to establish the relationship of units. So the first one is, for every 100 units, there is 1 ml of injection. So the question is asking, how many milliliters do we need if the patient needs 40 units? Okay, simply rearranging the problem will yield xml is 100 is 40 units over 100 units times ml. So these two cancel out and you will get 0.4 ml of injection. As in any problem, the main importance of ordination proportion is to establish the relationships between the units first. So next, Digoxin lanoxin pediatric elixir contains 0.05 milligrams of digoxin in each milliliter of elixir. How many milligrams of digoxin would be administered with a dose of 0.6 ml? So the initial concentration is 0.05 milligrams per ml of elixir. So if you're going to give 0.6 ml of elixir, how much will it contain? So rearranging the formula again, you have 0.6 ml over ml multiplied with 0.05. So compute the answer. We have 0.03 milligrams. So this is actual milligrams, sorry. So this is the answer to this question. So in a clinical study, a drug produced drowsiness in 30 of the 1,500 patients studied. How many patients of a certain pharmacy could expect similar effects based on a patient count of 100? So the rate is 30 is to 1,500 patients, 30 cases per 1,500 cases. So how much are we expecting if we have a patient count of 100? Simply rearrange the equation again. Sorry, this one is wrong. $30 times 100 over 1,500 equals x. You'll get an answer of 2. Next, a formula for 1,250 tablets contains 6.25 grams of diazepam. How many grams of diazepam should be used in preparing 350 tablets? So the ratio is 6.25 grams of diazepam is in 1,250 tablets. If we're preparing 350 tablets, how much do we need? How much is contained? So the x is on top. Simply rearrange the equation again. And you will have an answer of 1.75 grams. If 100 capsules contain 500 milligrams of an active ingredient, how many milligrams of the ingredient will 48 capsules contain? So if 100 is to 500 milligrams, how much will 48 capsules contain? So the x is on the bottom. Let's rearrange. X equals 48 times 500 over 100. So we'll have an x of 240 milligrams. Okay, so as the questions progress, you will only repeat the same process over and over again. The main important thing is to properly align the units on top and on the bottom. Otherwise, you will end up with a wrong solution. So each tablet of Tylenol with codeine contains 30 milligrams of codeine phosphate and 300 milligrams of acetaminophen. By taking 2 tablets daily, how many milligrams of each drug would the patient take? So each tablet contains 30 milligrams, that is 1 tab per 30 milligrams of codeine. And also 1 tab contains 300 milligrams of paracetamol or APAP. Now, you're taking a ratio of 2 tablets daily per week, 2 tabs daily per week, that is 2 tabs per day. So you have 7 days, that is 14 tablets. So 14 tabs, and you are asking for how many milligrams of each substance. Simply rearranging the formula will yield okay, so the amount of codeine is 14 times 30, 420 milligrams of codeine. Well, the other one is 4,200 milligrams of codeine. I mean, paracetamol. Next, a cough syrup contains 10 milligrams of dextromethorphan hydrobromide per 5 ml. How many milligrams of the drug are contained in a 120 ml container of the syrup? So the ratio is 10 milligrams per 5 ml. How many milligrams in 120 ml? Rearranging the formula, you will get 120 ml times 10 milligrams over 5 ml. You will get 240 milligrams of dextromethorphan hydrobromide. So in an intravenous fluid is suggested to deliver 15 milligrams of medication to a patient per hour. How many milligrams of medication are delivered per minute? So 15 milligrams per hour. How many are delivered per minute? Okay, so 15 milligrams is 1 hour or 60 minutes. We can already just divide this, and you will get 0.25 milligrams per minute. So biotechnology drug filgrastim is available in vials containing 480 micrograms of filgrastim per 0.8 ml. How many micrograms of the drug would be administered by 0.5 ml of injection? So the vial has a concentration of 480 micrograms per 0.8 ml. The question is asking how many micrograms per 0.5 ml. So the equation will yield 0.5 ml 480 micrograms over 0.8 ml. ml will cancel out. You will have 300 micrograms of your filgrastim. So next question. So a prescription drug costs the pharmacist $42 for a bottle of 100 tablets. What would be the cost of 24 tablets? So $42 per 100 ml. I mean tablets. Let's erase it. Sorry. This is for 100 tablets. What would be the cost for 24 tabs? So the missing is the price. Rearranging the formula, we'll get x equals 24 times 100 divided by 42. X would be 57 point. No, this is wrong. I think I had an error with moving. Let's try again. Sorry. So I already know that it was wrong because my answer was greater than 42, but the tablets were already for 100 pieces. So ideally, theoretically, the price for 24 would be less than the price of 100 tablets. So I already knew I was wrong. So again, let's start. 42 over 100. The cost for 24 tablets x. X would be 24 over 42 times 100. Oh, I see. I just made this mistake on my zeros. It would only actually cost $5.714. Okay, it was only $42, not $420. How many 0.1 milligram tablets will contain the same amount of drug as 50 tablets, each of which contains 0.25 milligrams of the identical drug? So each tablet, how many 0.1 milligram tablets will contain the same amount of drug as 50 tablets, each containing 0. Okay, so the ratio is 0.025 milligrams per tablet. We will be equating it. How many 0.1 milligram tablets do we need to equate a single tablet? Oh, I see. 0.1 milligrams tablet. X is 0.1 milligram over multiplied by 1 tab over 0.025 milligrams. 0.1 divided by 0.1 divided by 0.025, we get 4 tablets, but we have to multiply it by 50. So you actually have to produce 200 tablets of 0.1 milligram tablets to have the same amount of drug as 50 that contains 0.025 milligrams of drug. I don't think that's correct. I think the correct answer would be different, because you have 50 tabs that contain 0.025, so that is actually already 1.25 milligrams. So how many tablets would be needed to give 1.25 milligrams? X tabs over 1.25 milligrams. Then you have a 0.1 milligram per tab. Okay, so to give 1.025, we have to Bayesian proportion it. No, wait, I'll erase it. Okay, X tabs equals 1 tab multiplied by 1.25 divided by 0.1. I can't actually see the screen clearly because my microphone is in front of my face. So you need 12.5 tablets. This would be equivalent to the original 50 tablets of 0.025 milligrams. So acyclovir Zovirac suspension contains 200 milligrams of acyclovir in each ml. How many milligrams of acyclovir are contained in a pint of suspension? 200 milligrams per 5 ml x milligrams over 473 ml. 473 multiplied by 200 divided by 5 ml. You will have 18,920 milligrams of Zovirac. That's a lot. A metered dose inhaler contains 225 milligrams of metaprotenolol sulfate, which is sufficient for 300 inhalations. How many milligrams of metaprotenolol sulfate would be administered per inhalation? So this one is easy. 225 milligrams over 300 inhalations. So you only need one inhalation. Okay, all you have to do is divide 225 by 300. So by simplifying the ratio, you can already have the amount of milligrams per inhalation. So this is relatively easy. Or you can continue with ratio proportion, whichever is suits your taste. So a pediatric vitamin drug contains an equivalent of 0.05 milligrams of fluoride ion per milliliter. How many milligrams of fluoride ion would be provided by a dropper that delivers 0.6 ml? Okay, so 0.5 milligrams is equivalent to 1 milliliter. How much would be given in milligrams in 0.6 milliliters? So rearrange the formula. So you get 0.3 milligrams in a 0.6 ml dropper. So if a pediatric vitamin contains 1,500 units of vitamin A per milliliter of solution, how many units of vitamin A would be administered to a child given 2 drops of the solution from a dropper calibrated to deliver 20 drops per ml of the solution? Okay, let's take it one by one. So 1,500 units per milliliter. Okay, so the child was given 2 drops of a solution from a dropper that was calibrated to deliver 20 drops per ml of the solution. So we have to equate this first into ml. So 2 drops, we need to convert this to ml, so since our concentration is in milliliters, 2 drops multiplied by 20 drops per ml. So this is the calibration. Sorry, you're not supposed to cancel ml, you're supposed to cancel drops. One ml. So drops. 2 divided by 20, we'll get an answer of 0.1 ml. 1 drop is 0.1 ml. I mean 2 drops is 0.1 ml. So you can substitute it to the first ratio. You'll get the X amount of units. Okay, so let's rearrange the formula. 0.1 ml multiplied by 1,500 divided by 1 ml. You will get X units. So you have 150 units that it was administered to the patient. An elixir contains 40 milligrams of drug in each 5 ml. How many milligrams of the drug would be used in preparing 4,000 ml of the elixir? So the ratio is 40 milligrams per 5 ml. We're going to prepare 4,000 ml. How many milligrams do you need? So let's rearrange 4,000 multiplied by 40 divided by 5. We'll get X. So you need 32,000 milligrams of the active drug. An elixir ferrous sulfate contains 220 milligrams of ferrous sulfate in each 5 ml. If each milligram of ferrous sulfate contains the equivalent of 0.2 milligrams of elemental iron, how many milligrams of elemental iron would be represented in each 5 ml of the elixir? Okay, so 220 milligrams of ferrous sulfate. So this is one of those times that drugs are given in different salts. 220 milligrams of ferrous sulfate in each 5 ml. Each milligram of ferrous sulfate contains the equivalent of 0.02 milligram of elemental iron. Oh, okay. How many milligrams of elemental iron would be represented in each 5 ml of the elixir? So we don't need to actually use ratio and proportions for this one. We just need to convert ferrous sulfate into elemental iron. So each milligram of ferrous sulfate, so 1 milligram of ferrous sulfate, is equivalent to 0.2 milligrams of elemental iron. So that is actually 44. So ugly. 44 milligrams of iron per 5 ml. So this is what the question was actually asking. So at a constant temperature, the volume of gas varies inversely with the pressure. If a gas occupies a volume of 1000 ml at a pressure of 760 millimeters mercury, it was actually supposed to be millimeters mercury, what is the volume at a pressure of 570 millimeters mercury? Ratio is 1000 ml, 760 mm. It is actually mmHg. Then what is the volume? X ml at the pressure of 570. 1000 ml multiplied by 570 divided by 760. You get 750 ml. If an ophthalmic solution contains 1 milligram of dexamethasone phosphate in each milliliter of solution, how many milligrams of dexamethasone phosphate would be contained in 2 drops if the eyedropper used to deliver was 20 drops per milliliter? So the ratio is 1 milligram per ml. However, they used a dropper. We need to multiply it by how many ml was given. However, they used a dropper, so 2 drops were given. With a calibration of 20 drops per ml, you would have 0.1 ml that was delivered. So 1 milligram per ml multiplied by 0.1 ml, you have 0.1 milligram of your dexamethasone. Okay, I think this is the final question. A 15 ml package of nasal spray delivers 20 sprays per milliliter of solution. With each spray containing 1.5 milligram of drug, how many total sprays will the package deliver, and how many milligrams of drug are contained in the 15 ml package of the spray? So this is a 2-part problem. Let us first solve the first one. How many total sprays will the package deliver? So you have 15 ml that delivers 20 sprays per milliliter. So this is very straightforward. 15 times 20, we have 300 sprays. Next, how many milligrams of drugs are contained in the 15 ml package of the spray? So we already have the amount of sprays from the first problem. Let's use this in our second part of the problem. 300 sprays times each spray contains 1.5 milligram of the drug. So one spray is 1.5 milligrams. So 300 times 1.5, I think it's 450 milligrams. So the whole package of 15 ml contains 450 milligrams of drugs. So I think this would be it. This is the final problem. So I hope you study well. Use your book. The answers are also in your book if you want to solve them independently.